Hello, good morning. So this is our first session for logic circuits and switching theory. I would like to make a roll call for my students. So we have Abrila Lemuel, Justine, Ambanta Jexter, Annie Aaron, Artamia Victor, Bren Balyaran, Joan Bo, Jezimel Berizo, Doris Bernales, Rafael Castilla, Rusty Condeno, J. Lord Cristobal, Ruben Del Valle, Carl Delin, J. De Maano, Frederick Donor, King Endaya, J. Lord Esparza, Julea Falogme, Samuel Ganigan, Ian Gesalva, James Martinez, Gerald Mente, Kedis Osano, Marian Pajaroja, Cal Palmes, Ajay Pesado, Justin Pesado, Amina Puerto, Jennifer Relos, Antonio Rivero, Jerome Rodriguez, and Donald Tagay for a total of 33 students for Bet EMET first year. So, what's up? I hope you're doing fine. Nasa bawal lumabas, sabi ni Kim Chu. Ayan. So, welcome to Digital Electronics Chapter 1. Pero hindi to isang session. So, normally, this takes around 2 to 3 sessions for Chapter 1. So, if you're going, please download the materials. So, the learning outcomes for Chapter 1 is, so at the end of this chapter, so the students must be able to explain the block diagram for digital electronics and then discuss the different number system and conversion from base n to base 10 and then do special conversions among binary, quaternary, octal, and hexadecimal. Then determine the truths complements and R-1's complement and identify different binary codes such as the BCD, the gray code, and the +3, XS3. Okay, so for introduction, we have digital system is primarily represented by two values. So we have 0 and 1. So the value of 0 could mean 0 volts or off, while the value of 1 means 5 volts or on. So if binary is represented by an LED, the light is off for 0, and for if LED is on, so it has a value of 1. So let's start with the basic block diagram of a digital computer. So as you can see in page 1, so you have basic block diagram. So we have input, memory, output, control, and arithmetic. So that's the basic block diagram digital computer. So for input, so you have the operators, from operators or from users. So as an input, we can have keyboards, camera. Okay, so for the output, we can have monitor or LED display or LCD. Okay, then for this subject, for logic circuits, so we have the controls. So hopefully you will learn how to design for a digital controls. And then we have a simple arithmetic. We can perform simple arithmetic using digital designs. Okay, and then the memory. Okay, so if you're going to have your logic circuits too, or for engineering logic circuits, so they do have memory, so that includes flip-flops, but that is beyond our topic. So for this subject, so we will learn more or less about input, controls, and output. So at the end of this subject, so you should be able to learn how to design a digital control. Okay. So we have, okay, let's proceed to number system. So for a start, so we have different number systems. So we have base 2. For base 2, base number description symbol. So for base number 2, so it's called binary and the valid symbols are 0 and 1. For base number 3, so we have ternary. So for base number 3, so we have ternary 0, 1, 2, and then for base number 4, 0, 1, 2, 3. For base 5, so we have quinary and the valid symbols are 0, 1, 2, 3, 4. For base number 6, so we have centenary 0, 1, 2, 3, 4, 5. For base number 7, septary 0, 1, 2, 3, 4, 5, 6. For base number 8, so we have octal 0, 1, 2, 3, 4, 5, 6, 7. For base 9, it's called nonary 0, 1, 2, 3, 4, 5, 6, 8, 7, 8. 0, 7, and 8. And then for decimal, base 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're accustomed to base 10. You've been using this since kindergarten, or even before you went to school. And then for base number 11, it's called undecimal. But take note that you still have 0 to 9. But after 9, you have A. And then for 12, you have dodecimal. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then after 9, you have A, B. And then for hexadecimal, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, you have A, B, C, D, E, F. So usually in a binaries, in a digital design, so we usually use binary and hexadecimal. Okay, so yeah. But it's interesting to learn about different number system to enhance your brain capacity. So if you learn something new, so your brain will be forced to form new connections, new dendrites, new axons, so you'll become more intelligent. Okay, so let's try with decimal. So you are accustomed to this. So let's discuss decimal. So decimal is a number system with a base number of 10. So again, so it had the valid symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So from 0 to 9, you have 10 valid symbols. So after 9, okay, after 9, so the least significant bit becomes 0, and then you add 1 to the left side digit. So nagkaroon tayo ng increment. Okay? But take note that this becomes 0, and then you add 1 here. Okay? Such that the counting is again 0 to 9, but take note that the left side is 1. Okay? Such that it becomes 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So, since the valid symbol for decimal is only up until 9, so what's next? So 9 goes back to 0, but you have to increase the most significant bit by 1. So we'll have an increment of 1. So, so the previous number is 1, 1, 9. So the next sequence would be 2, 0. Okay? So we added 1 here, such that the counting continues 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, until it becomes, so what's next for 29? So as we all know, so 9 goes back to 0, but you have to increase the 2 by 1. That's such that it becomes 30. Okay, so I know you all know how to count in decimal. Okay, so that is for decimal. Okay, so I hope everything's clear. So let's proceed with binary. So binary is a number system with the base number of 2. So the valid symbols are only 0 and 1. So let's have an example. So 0 and 1. So what's next to 1? So you have to go back to 0, but you have to increment. When you say increment, that's plus 1. You have to increment the left side or the most significant bit by 1. So from 0, 0, the left side number here is actually 0, 0, 0, 1. Okay? Such that if you're going to increase the number following 1 is 10. Okay? So the 1, you have to go back to 0, but you have to increment the left side, the left number by 1, such that after 1, so it becomes 10, and then increment the right side, the least significant bit by 1, so it becomes 11. But what's next to 11? Again, so for binary, the significant numbers are 0 and 1 only, or it is only represented by 0 and 1. So after 1, you have to go back to 0. And then you have to increment the left side number. Okay? So are going to increment so after 11, what's next? So it becomes 100. And then continue counting 101, 110, and 111. After 111, you have to go back to 0. And then you have to increment the left side by 1. So how are we going to do that? So after 111, therefore, the next number would be, for binary, is 1000. Then followed by 1001, then followed by 1010, then followed by 1011. So after 1011, what's next? So again, you add 1. So the next number would become 1100. Of course, after 1100, so we have 1101, 1110, 1111. And then after 1111, what could be next? Can you guess? So you have to increase it by 1. So there's no only 0 and 1. Take note, there's only 0 and 1 as valid numbers. So what's next would be? So take note that 1111 has 4 digits. So therefore, the next would be, has to be 5 digits. So it's actually 10,000. Okay, 10,000. So after 10,000, you have 10,001, 10,010, 10,001, 10,010, 10,011, and can you guess what's next? So you try. I want you to try what's next. And then guess what's the answer? After 10,011, what could be the answer? And this is message me the answer. What's next to 10,011? And then for quaternary, for quaternary. The quaternary is a number system with a base number of 4. It is represented by 0, 1, 2, and 3. So take note, for quaternary, you only have 4 valid symbols. Okay, so we have 0, 1, 2, 3. Okay, so let's start to count using quaternary. So we have 0, 1, 2, 3. So after 3, you have to go back to 0. You have to go back to 0. So what's next to 3? So you have to go back to 0. But you have to increase the left side by 1. So it becomes 10. Such that it becomes 10. Then continue counting. 10, 11, 12, 13. So after 13, so it has to go back to 0. But you have to increment the left side by 1, so such that it becomes 20. Okay, then continue counting. 20, 21, 22, 23. After 23, guess what? So the 3 has to go back to 0, but you have to increment the left side from 2 to 1. Okay, from 2 plus 1, such that it becomes 30. Of course, 30, 31, 32, 33. After 33, 3, go back to 0, but you have to increment the number on the left side. So 3 plus 1. For quaternary, 3 plus 1 is not 4, but rather 10. Because this is quaternary. Then counting continues. 101, 102, 103. So again, 3. After 3, it has to go back to 0, but you have to increment the left side numbers. 10 plus 1, so it becomes 11. 110, 111, 112, 113. So what's next to 113? So it's actually 120. Of course, 120, 121, 122, 123. After 123, so we have 130. Okay, so after 130, 131, 132, and 133. So what do you think would be the next number? Message me. Okay, so you write binary, quaternary. So next is this second number is, guess the second number. Okay. So we already have a quiz here. So this is considered a quiz. Okay. How about for octal? Okay. So for octal, so we have a number system with a base number of 8. So 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so again, just like in quaternary, binary, and decimal, so the valid symbols are, we have 8 valid symbols starting from 0, 1, 2, 3, 4, 5, 6, 7. Okay, such that after 7, you have to go back to 0, but you have to increment the left side of the numbers. So this is actually 0, 7, so it becomes 10. 10, 11, 12, 13, 14, 15, 16, 17. So what's after 17? So again, the valid symbols are only 0, 1, 2, 3, 4, 5, 6, 7. So the 7 here has to go back to 0. And then for the left side, increase it by 1. So it becomes 20. Okay, becomes 20. So after 20, so we have 21, 22, 23, 24, 25, 26, 27. So after 27, what's next? So again, the 7 here has to go back to 0. And then you have to increment the left side by 1, such that after 27, next number would be, You guess it right, 30. Okay, so 30, 31 up until 37. Next is, after 37 is 40. Then again, 41 to 47. Then you have 50. Okay, and so on. So, what if what would be we have the counting is now in 76, then 77. Guess what's next? Okay, so that would be your third question. And lastly, so we have hexadecimal is a number system with the base number of 16, so represented by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. Okay, so again, these are just an example. So this is also applicable in other number system. Okay. Yeah. So let's discuss hexadecimal. Okay. For hexadecimal, so it has 16 valid symbols. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. To make up for 16. Okay? So for hexadecimal, after 9 is not 10, but rather A, B, C, D, E, F. After F, that's when you'll have 10. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. After 19, we have 1A, 1B, 1C, 1D, 1E, 1F. After 1F, so we have 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 2A, 2B, 2C, 2D, 2E, 2F. After 2F, what do you think is next? After 2F, so we have 30. Okay? Then 31, 32, 33, 34, 35, 36, 37, 38, 39. After 39, so you have 3F. After 39, we have 3A, 3B, 3C, 3D, 3E, and 3F. After 3F, what do you think will be next? So we have 40. So again, counting continues. 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. What's next? So we have 4A. Then we have 4B, 4C, and then 4F. Then we have 50. After 4F, that's when you're going to have 50. Okay? Then you continue counting 50, 51, 52, 53, again 59, 5A, 5B, 5C, 5D, 5F. Okay? So my next question is, what do you think will be the number after 9F? After 9F. So that would be the fourth question. Okay? So please leave a message. Okay, leave a message to me. Okay. You may do so. Please chat me in MS Teams about the answer for the 1, 2, 3, 4. What's the next number? Okay, 1, 2, 3, 4. Tell me the answer in MS Teams. Please write your name. You have your name, but anyway, you have your names there. Just give me the answer. What's the next number? Okay? So I'm going to wait for your answers today, and then after that we'll continue the after that, please answer the assessment number 1.1. Okay, so if you have any questions, please feel free to message me. That's all. Thank you. If you have any questions, please message me.